Okay, for this next one, we're starting out with a square root function. Again, we're going to create the table. This one, we do have a domain restriction on this one that we should talk about right away. It is a square root, and we learned recently that you can find the domain of a square root function by taking whatever's on the inside there and saying it must be greater than or equal to 0. Then if we solve that inequality, we get x is greater or equal to 5. So when I'm filling out my x values on my table here, I don't want to put any x values that are less than 5. So I'm going to start with 5 and then 6. And then beyond that, I'm going to think about it before I put anything in there. So let's see, if I put in 5, I'd get 5 minus 5 is 0. The square root of 0 is 0. Put in 6. 6 minus 5 is 1. Square root of 1 is 1. If I were to put in 7, I'd have, well, let's go ahead and put it in. I'd have 7 minus 5, which is 2, and the square root of 2 is, well, just the square root of 2, which is not a nice pretty number, but I know on the coordinate plane that I have to work with down here, that's going to be the last x value that I can actually fit on there. If I did want to get another nice one and I had a bigger coordinate plane to work with, I would want to think about what would be the next nice x value to use. So let's see, I would want to end up with a 4 inside the radical next time. So to make that happen, I would need a 9 for my x. 9 minus 5 would be 4. The square root of 4 is 2, a nice number, which is why I would want 9. And just for sake of having a little extra practice, let's think about what the next nice number would be. My last y value was a 2, which would mean that inside the radical I had to have a 4. My next whole number y value would be a 3. So that would mean inside my radical I would need to end up with a 9. So I would need to know, well, what minus 5 would give me 9. So that would be a 14. Then if I go back and calculate it, 14 minus 5 is 9, square root of 9 is 3. But of course, those are not going to fit on my graph. That one isn't, and that one isn't either. So the only ones I'm going to plot are the 3 that I have on there right now. So let's go ahead and plot those. So 5, 0, 3, 4, 5. Here we go. 6, 1. And then for 7 square root of 2, I kind of just need to estimate what the square root of 2 is. Now I know it's bigger than the square root of 1, but it's smaller than the square root of 4, and it's closer to the square root of 1 than it is to the square root of 4. So it should be closer to 1 than it is to 2. So when I put it on here, I'm going to put it a little bit above the 1. And then I can connect them. Now I'm ready for the inverse. So I'm going to switch my x and my y on each of the points that I was able to fit on there. And of course, I could switch the x and the y on the other 2 points that we found, but they're not going to fit on the graph, so it probably would not be very beneficial. So 0, 5, 1, 6, and square root of 2, 7. That would be about right there. Square root of 2 is about 1.2 maybe. And then connect those. So these look a little bit like parabolas, but just half of parabolas. Okay, I also want to fit in on my graph there the line of symmetry, which is y equals x. And I need to move this down a little bit. And connect them here. There we go. Oops, that's okay. So there's my line of symmetry, y equals x. I can see if I were to fold this paper, this virtual paper across that line, the two curves that I drew would lay right on top of each other. And that is the relationship between a function and its inverse there. Okay, so now we're ready to talk domain and range and whether or not these two things are functions. So I'm looking at f of x first. The domain of f of x, that's my navy blue one up here. Looks like the smallest x value that's there is a 5, which we kind of talked about already. So we'll say x is greater than or equal to 5. And for the range, well, it looks like the smallest y value on that is a 0. And so its y is greater than or equal to 0. And to tell whether or not it's a function, I would use vertical line test there. Any vertical line that I tried to draw on that one would only intersect that curve at most one time. So this one is a function. And now I'll go to f inverse of x. So I'm looking at the light blue one. For the domain, it looks like it starts at the y-axis, which has an x value of 0. Then it goes to the right, so that would be all x is greater than or equal to 0. And then for the range, the lowest point has a y value of 5, and it's everything above that, so that would be y is greater than or equal to 5. And to tell whether or not it's a function, I would use the vertical line test again, and I would see that it is in fact a function there. Now, one thing I want to point out this time that I did not point out in the previous ones is that there is a relationship here. The domain of the function gives you the range of the inverse if you switch the x and the y, and vice versa. The range of your original function gives you the domain of your inverse. Okay, lastly, I need to find the equation of my inverse. So I'm going to do that out to the side here, just like I've been doing on all the others. That didn't come out right. There we go. Okay, so I'm going to take my original function there. I'm treating the f of x like it says y. So I could make this say x equals square root of y minus 5. And then I want to solve this for y. So the first thing I would need to do is get rid of the radical. And the operation that would do that would be squaring. So that would give me x squared is equal to, on the right, the radical and the square just cancel each other out. So it just leaves y minus 5. And then to get the y by itself, I would add 5 to both sides. So that would give me x squared plus 5. Okay, so this would be my inverse relation, but I know a little bit about the graphs of these things, and the graph of this one should be a parabola. It's a quadratic function. And if I look at the graph that I drew, that light blue one, I see that it's not a parabola, it's only half a parabola. So I actually have to adjust this one a little bit. I have to restrict its domain so that it only gives me the piece of the graph that it's supposed to. So I would have to say x squared plus 5, but then after it I'd have to say, comma, x is greater than or equal to 0 only. That way it would cut off the left half of the parabola and would give me just the reflection of the piece that I had from the original function. So I'm going to put that down at the bottom here. So this would be x squared plus 5. And then I put a comma next to it and say, but only for x values that are greater than or equal to 0. Now I have to include this piece on here because that's not the natural domain for this parabola. This parabola should have both the left half and the right half. But in order to actually be the inverse of the function that I was given, I can't have the left half of it as well. Okay, now you answer the questions on the Google form.